minimum sum of values by dividing array. So for this problem, we are giving an array nums, and we are also giving an array add values. So the question just led us to split the nums array into several parts. So for example, if the length of the add values is m, so we just need to split the array into m parts. So for example, 1 and 4 are going to be the first part, and then this is the second part, third part, and fourth part. Yeah. So for 1 and 4, the result is going to be 0. So yeah, it's gonna 1 and 4 equal to 0, and the second, this is 3 equal to 3, and the third 3 equal to the third 3, and the last 2 equal to last 2. Yeah, we just need to split the nums array into m parts, and each part gonna equal to the values inside the AND array. Yeah. So how can we solve the problem? Let's just check what is m and what is n. Yeah. So m is the AND values. The length, it is just 10, and n is 10 to the power 5. Yeah. So we might think about maybe we can solve it by using brute force. Let's just try to check if that is possible. Yeah. Normally for brute force, I mean DFS with memorization. So we're going to prepare n at m, going to equal to length of the nums array and the length of the add values. Yeah. Now we're going to define a DFS function, and we're going to prepare some variables. As this is going to be a dynamic programming, we're going to use a class. Yeah. So the index of the array, we're going to define it as I. So the index of the nums array is I, and how many parts, we're going to define it as j. And what is the current add values? So for example, 1 and 4, we need to record the final result. Yeah. And here we're going to use this add as the current add values. If we are still calculating. If it is one of the parts, so we're going to record it. So this add values is the current add values. For example, 1 and 4, add 3, it's going to be the current add values. Yeah. So the condition is that we're going to check I. If I equal to the length of the array, it means we're gonna return a 0. So if we can split it into m part, otherwise we're gonna give it infinity, because we are going to calculate the minimum possible sum values of the m subarrays of nums. Yeah. So another condition is that we're gonna check j. If we can split it into m part, we can return a 0 if I equal to n. Yeah. If we finished all of the nums array, else we're gonna return infinity. Now, if it is not, we can continue to calculate the add values. So add gonna with a value of nums I, we're gonna accumulate the values, and the current, we're gonna prepare our result if we do not want to split it. Yeah. So if we do not split it, it's gonna be DFS I plus 1. Here it's gonna be j because we didn't split it, and we're gonna use this value f. This is not splitting. Yeah. Now, what if we want to split it? Yeah, but the condition is that we have to check. Yeah, if this add result equal to the add values of the j. Yeah. So for example, if 1 and 4 equal to 0, so this means we're gonna split it. So we're gonna choose the minimum of the result with DFS I plus 1. We're gonna go to the next number and z plus 1 because we want to split it. And lastly, we're gonna need a -1 because -1 add any value gonna be on this value. So this means, yeah, we just need to recover it as a -1. Yeah, so minimum of the DFS plus a value of nums I, because according to the question, each part, yeah, gonna be the last number. Let me check that. Yeah, we're gonna need to calculate the sum of the values, but each part is gonna be the last number. As you can see, this is 4 plus 3 plus 3 plus 2. It's gonna be the last number inside of the splitting part. I think it is mentioned, yeah, the value of an array is equal to the last element of that array. So this is a subarray. The value of the array is gonna be 4 instead of 0 or 1. Yeah, this is why we're gonna plus a nums I. So finally, we're gonna return the result. Now let's just record the final result. It's going to be DFS 0, 0, and -1. So we're going to return a result if the result not equal to infinity, else we're going to return a -1. Yeah, maybe you think the time complexity is going to be I times j times the add, it's going to be 10 to the power of 4 times j, they're going to be 10, and times another add, and what is the value of this add? Yeah, so here is the question. What is the value of this add? Is this value add 10 to the power of 4 log 10 to the power of 4? No, it is not. Because while we are doing the add calculation, so for example, this is 110, 1111, and something 11. While we are doing the add calculation, so the value is going to be smaller and smaller. It can never become bigger. Maybe next time it's going to become 10011 something 00. Maybe for the next time it's going to become 00 here 11 something 00. Maybe for the last time the final result is going to be just 0. Yeah, so how many of such cases? There are going to be only like 30 cases if the number is 10 to the power of 9. Yeah, so this means for the add, this is just like log n, it's going to be 30. So the final time complexity may be 3 times 10 to the power of 6. This is why it works. Yeah, let's just check. So the value is just 10 to the power of 5. Actually, it means it is less than 20. Yeah, or less than 15. That is why it works. Let me just run it. As you can see, it works. And now let me just submit it. Yeah, as you can see, it passed for all testing cases, and it's pretty fast. Yeah. So the idea is that if we fix this I, and if we fix this I and j, and what about this add? How many cases of add? There's only 30 cases. Yeah, instead of less of the array. Yeah, because for this add values, by using the add, it's gonna become smaller and smaller. That is why we're gonna. Yeah, that is why we can pass. I think that's all about it. Thanks for watching. See you next time.